Hello everyone, welcome to my channel. I'm Ivan. Today I want to share the topic is connected sets. So let's just introduce about the breakout of connected sets. So breakout of connected set we can divide it into two parts, which is connected in topology and connected in real analysis. So first we introduce about connected in topology. Connectivity is a fundamental topological property that reflects the intuitive notion that a set has no back points. A set is disconnected if it can be divided into two parts, and no point on one of the parts is the limited point of another part. If such a division is impossible, then the set is connected. Also, connectivity is important for categorizing graph in topology, especially in the case of removing points. For example, we remove a point for an arc, so the arc is become disconnected. In the late 19th and early 20th centuries, mathematician George Cantor and Henry Poincaré formalized the notion of the connectivity, which they also used to study the properties of surface and develop algebraic topology. So, let's introduce about the second one, connected in real analysis. The concept of connectedness arises from effort to formalize continuity in the study of function and space, particularly in real analysis and metric space. A set is connected if it cannot be divided into two non-empty, disjoint open subsets. Alternatively, a set is disconnected if a continuous function map is to a closed interval with from 0 to 1, or it can be split into two relatively open and non-empty subsets with union from the set. In essence, a set is connected if it lacks such division. So, after we introduce about the breakout of connected set, so what is connected sets? Let's introduce about the definition of connected sets. Let A be the subset of Rn, so we can say that A is connected if there doesn't exist a pair of open sets U and V that separate A. So, let's introduce about the theorem of connected set, which is the intermediate-vary theorem for connected sets. So we let D be the connected subset of Rn and lay that f is a function defined of D that from D to R. So if function f is continuous, then fd is a interval. So let's prove about for this theorem. Since D is a connected subset of Rn, so it cannot be split into two non-empty, disjoint open subsets in subset topology. Let fd equals to for y in R, y equals to fx for some x in D. So to prove that fd is an interval, so we need to show that if a and b in fd and c in R satisfy that a less than c and less than b, then we know that c is in fd. So by definition of fd, there exists a point that x1 and x2 in D, so such that fx1 is equal to A and fx2 equals to B. So we assume that A is less than B. We consider that set D prime is equal to for x in D, fx is less than or equal to C, where C is a value such that A less than C and less than B. Since the function f is continuous and the D is connected, the pre-image of intervals under f are connected subsets of D. The image of a connected set under a continuous function is also connected. In R, the only connected subsets are intervals. Thus, fd cannot have any gaps. In f and b in fd, so all the intermediate terms vary between a and b but also belong to fd. Therefore, we know that fd is an interval in R. So, talk about the theorem. Let's have an example to show about that. So we let the question be, let D equals to for x and y in R square, x squared plus y squared is less than or equal to 1, which is a circle. So D will be the closed unit in R square. So we define that f in from D to R. So fxy is equal to x. So we do the solution. The function fxy equal to x is a projection onto the x coordinates. Since fxy equal to x, it doesn't have any y. So this is the linear function in x and y, and continues a rate on R square. The domain D consists of all points xy satisfying x squared power square is less than or equal to 1. This means that x in the interval from -1 to 1. So we know that x is achievable for any x in -1 to 1. Therefore, the image of D under F is Fd equals to -1 to 1. So the closed interval -1 to 1 is connected because it is an interval in R, since we know in definition. The image of closed disk D under Fxy Ex is Fd equals to -1 to 1 where it is in R. So this is all the example. So let's show about the reference. This is a reference that we all find for online and for textbooks. For the first and two we find for textbook, I will put all the textbook inside the video, and also the link. You guys can go online and search about that. So thank you everyone for watching today's video. If you like for this video, please like, share and comment for this video. Thank you everyone.